Good morning, everyone. Welcome to this presentation this morning by Professor David Stern. So David is a professor in the Art Corden Department of Economics in the Crawford School of Public Policy at ANU. He's an energy and environmental economist whose research focuses mostly on the macroeconomics of energy, air pollution and climate change. He also works on research assessment using meta-analysis and bibliometrics. David has published widely in economics and natural science journals, including Nature, Journal of Economic Literature. He's currently co-editor-in-chief of the Australian Journal of Agriculture and Economics and fellow of the Academy of Social Sciences in Australia. David is the lead author for the chapter on drivers, trends and mitigation in Working Group 3's contribution to the IPCC's 5th assessment report and a review editor on the 6th. So it's a great pleasure that he's here today. I'm introducing, on behalf of Tim Neal, who was going to be hosting David, but is currently stuck in an airport somewhere in the US. He was back yesterday morning, but it's not going to get here, I think, until later today or tomorrow. Yeah. So
Initially he said, I hope maybe I might still get on Wednesday, and he said, nah, not looking good. So
it's not going to do it at all. Which is a great shame, but David's still here, so he's going to give us a talk on the macroeconomic impacts of disasters.
Okay. Thank you for the introduction, and thank you for reminding me. Pity that Tim is not here. Yes, I'm talking about two related topics. Sort of there are two parts to this. So disasters, it's a fairly complete paper, and climate change, quite preliminary research, and talk about macroeconomic impact, where basically boils down to what's the effect on the GDP of these things. Now I'm not getting. There we go. Introduction. So they're related but different, and the way they're different means how you need to modify your modelling to take into account the difference between these things. So disasters, of course, are discrete events that happen maybe a very short period. A drought might be a bit longer. Whereas climate change is continuous change over decades, centuries, so forth, right? So that difference in the type of process means the difference in the kind of modelling that really should be used to address that, and that's kind of part of the connections I'm bringing up between the two things. So, sort of brief overview to disasters and climate change. So, the debate is between are the effects negative, what you'd expect, disaster hits things, or positive because the recovery maybe outweighs the initial disaster. I mean, we're looking just at the GDP, not at other things like environmental impacts and human health and so forth. But if we just look at that alone, what is the effect? And then there's just also debate about, is this a permanent effect or just a transitory effect and the economy bounces back? The climate change is kind of similar debate in this literature on the, what people are doing here is they're using historical climate change and economic growth to try to get some assessment of what is the impact, and then get some numbers they can use to calibrate an integrated assessment model is the main sort of use case for this, or in cost benefit analysis, putting some sort of social cost on carbon. They're basically large literature. People try to estimate from historical data what the effects are. So one of the key questions here is does it affect the rate of economic growth permanently, or is it more of a transitory effect? And when climate change ends, then the economy bounces back a bit, but maybe a different level, and therefore that's called a level effect. So there's a bit of debate there on how permanent the effects are or not as well. So a disaster paper. Joint work with my PhD student, Xueting Jiang. She just got a job at CSIRO, so she's no longer my PhD student. And so main thing we do, we disaggregate in the different sorts of impacts. You'd be surprised how many papers don't do that. We find a positive effect actually of floods on GDP, particularly in developing countries. And we try to look at what is the channel through which this affects the economy, and it comes out that it's initial increase in government spending. We find that econometrically is kind of what you'd expect to see as if there's going to be a positive effect, that's going to be the positive effect. Climate change, this is very preliminary exploratory work. The story is we wrote an expression of interest with Ben, with Andy Pittman, with Tim Neal for the ARC Discovery Project. It was rejected, but I thought, oh, well, I should do some background research on this for writing a proposal. So this is just some background research for writing a proposal. So it's a work in progress and but sort of pointing well what is the direction here. Okay, so disasters, why have I got this as a picture of a disaster? Well, it turns out it's a disaster database. There's an awful lot of cold spells in India in the disaster database. So I thought that was a bit unusual, and picture of that. So these are the different paths we could have. I'm happy to take any questions as we go along as well. So basically, normally it'd be like otherwise 3/4 an hour and then 4.5 questions. Yeah, so, sorry?
Well, a quick question. So, well, maybe it's not quick, it's not. So using GDP, I mean, as you might think that, yeah, sure, I'm spending, GDP's gone up, but I'm as a consumer, I'm not getting my desires met because I'm spending my money and borrowing money to say rebuild my house, rather than say spend be exciting and having really nice meals out.
Yeah.
So I just wonder do you need to, in the long run, to be a bit more subtle about these issues? I mean, I don't want to.
You need overall to include more different sorts of impacts. But the question here is it, as you see in these diagrams here, so the first one is a negative effect, and when it's transitory and we get back to where we were before. Scenario B is there's a negative effect initially, and then there's a bounce back as a positive effect, and we sort of back where we started off before. This one is a negative effect and it's permanently worse. So I'm not very happy with that one. And then there is one where you end up with a better house than you started with, which is often called build back better. So the idea is that, yeah, there is some destruction of capital in the economy, but then the rebuilding is better than what was there before, and we end up on a higher path than we would otherwise be. So there's a debate in which of these applies. And of course, there are lots of other impacts that are not captured by this, and a comprehensive accounting would have to include all of them. The same for damage functions from climate change in integrated assessment models. Okay, so looking at all existing literature, there's a meta-analysis by these guys Klomp and Valkix, I think. So they find there's a negative but only transitory effect of disasters on GDP, and for floods or hydrometeorological disasters, the effect is not statistically significant. They also find signs that there's something you want to do with meta-analysis is look for publication bias, that there seems to be some publication bias that censors positive results. So if you find a positive result, it's harder to publish it, which you're not having much luck trying to publish this paper, so, which finds positive results. So I don't know, yeah, so when you look at the average of a literature, it's not necessarily the truth of what is really out there, just of what has been published. And one of the most recent papers by this guy, Jesus Crespo Quaresma, he found no significant effect overall, and he aggregates all the different disasters, all the different climate weather disasters together, doesn't distinguish between them. Maybe there's a bit of a trend here that older research maybe is showing more of a negative effect, but not significant, and then we're sort of finding some positive effects. But of course, there are positive effects out there, and also ones which were never published. So the data we use to look at this is this MDAT database, which is quite widely used. There's lots of events all around the world. Over the last century, we're just looking since 1960. And the disasters are in there not based on sort of the sort of physical size of a disaster, but based on the impacts. Is the death toll above 10? One of these will get you into the database. Is more people affected 100? Was a declaration of state of emergency? It's going to depend very much on local institutions. Was international assistance requested? Again, will depend very much on the local situation rather. So that is how disasters have been added into this database. So some of the other previous studies also use the same database. So looking at the different sorts of disasters, India often shows up with lots of them. So I don't know, India has a lot more heat waves than Sudan does. Is that real or not? Or is it based on their willingness to declare disasters? Okay, I don't know. When we get to the cold spells, yeah, India has more cold spells than anyone else in terms of disasters. But the thing is, they declare this does reflect to some degree adaptation to climate. Whereas a cold spell in India, it's bad news. Poland is worse than Russia, apparently, right? So milder climate, which does sometimes get cold weather, you can end up being registered in a database as having more events. So this is something to bear in mind on the analysis of the results. Probably a bit more objective is the floods. There are also a lot of these floods. So India and China have the most occurrences. We're not counting in our research a number of these events. This is just sort of illustrative to give you some idea of how these things are distributed. And droughts, China apparently led in the number of observed or declared drought disasters. Okay, so we use this database, even though obviously it has some shortcomings. Yeah.
Presumably, so developed countries, I'm looking at the UK, which I generally live there, seems to have very little disasters. I mean, do developed countries essentially are less likely to call on help and more likely to, in a sense, just deal with it as part of it? Possibly. Wondering about bias in the data set.
That is possibly a bias. A smaller country is going to have fewer, of course, and a larger one's got more area to be hit by something. Yeah. So yes. So if you don't declare disaster or request international assistance, or the death toll is lower and so forth. So things that populate, lots and lots of things are feeding into this measure of disasters. So that is to bear in mind when you look at any analysis that uses it. The question is there anything better out there? And we haven't seen anything that seemed to be any better than that currently. The other data is fairly standard.
Can I just ask, sorry, you said that you don't include some of that data when you're showing the maps. What's the threshold for when you do include it?
So we're doing we're including all the data that's 1960 to 2019 that's shown in the maps. What we're not doing is the data is not, there are a lot the number of disasters there's a disaster declared of this type in this year. What happened to the GDP in that country in that year? So the number of disasters is not that critical to the result we're going to get. India has a lot, unless of course the degree of effect is if they have lots of have lots of disasters really don't have a lot of impact. When they have disasters have a lot of impact, that will affect our result. But so our variable is not number of disasters that you see per country as you see here. It's was there a disaster in this year, and then what happened to the GDP in that country in that year.
So it's completely irrelevant whether there's 1 or 10 disasters, or do you?
Yeah, we're not counting whether there was one. Well, there's probably floods. There could be multiple ones, probably. Okay. But yeah, we're not actually counting that. No.
Okay.
Yeah.
I'm just actually thinking about growth. How should I think about the counterfactual of this, right? Because in the end, these countries we're expecting them to grow when they actually have more government expenditure. Maybe perhaps natural disasters somehow tilt us towards more productively using this expenditure. Maybe, there are more technical changes or innovations that are coming along.
Well, that's this scenario here.
Yeah. So do you have any empirical evidence to support a more productive use of this government expenditure beyond just telling us?
We don't actually have a way of looking at that. So no, we don't look at that. We look at whether the effect is just short run or is a long run effect. Yeah. So we don't look at beyond it's positive and it was permanent that what was it, and we look at well which category of, as you'll see, which category of GDP was affected, but that's as far as we go. We don't look at like is productivity affected. Maybe something we should look at. So maybe it's a good idea. Yeah.
Can you come back to the time?
Which one?
Time plot. The
Which?
one. Yeah, just the
Scenarios.
scenario.
Yeah.
Yeah. Can I ask like how long is the time period? Like
It's just very schematic. So
there's no specific like
Yeah.
will be
we're
recovered.
looking just at a few years. So we're looking at annual data and a few lags. So yeah. So I think most studies look at that rather than very long term effects. Yeah. So we just basically test whether these lags to see significant, including the model. If they are, if not, we truncate it there and stop adding. Right. Okay. So the model, yeah. So it's growth of log GDP per capita here, and these are dummy variables for there was a disaster in that year in that country. Country I in year T. There's lags of them as well. Test 4, and the different disasters: heat waves, cold spells, floods, and droughts, as I showed on those maps, and there are also some other fixed effects in the model. So basically, we estimate this model. There's a more complicated one where we also look at break between developing and developed countries. Some interactions there. So these are some results from this. So in each case, these are different sorts of disasters. First year is just 1 year impact, and long run is then multiple years of impact. What's the sum of the coefficients? And so looking at floods, the floods in the first year already have a statistically significant impact, which is positive, but it turns out globally this was positive, statistically significant, but when we break down by the two different groups of countries, it's in developing countries and not nothing much happening in the developed countries. So whatever the recovery sort of balancing the impact in the developed countries, it's not a boost up. That's what we're finding in the data. Maybe you think intuitively it might be the other way around, but that's what we found. Generally, these effects are in developing countries rather than developed. So so assuming disaster has some negative effect, recovery is sort of cancelling it out in the developed country. Yeah.
Just wondering, can you exploit state within the country, state growth? Because
that
provinces, right? Because then I think the identification would be a little bit better. Because now the variation comes from different countries.
Yes.
So I'm
We
just
do weight the regressions to take to.
So if you put a country fixed effect, what is going to happen, for example?
There are country fixed effects, yes. And then we weight the regression. There's more weight on the larger countries and less weight on the smaller countries as well.
Because I'm thinking if you have got, using state variation, maybe
It
you
would
can
be
say
nice.
something better.
We need comparable data set for like those internal states on the GDP. Maybe for some countries we could get that. And attributing the disasters to particular states within the country, I'm not sure that is always available. So yeah.
You mentioned that you are giving some weights for the larger countries, and
Yes.
so is it like the geographically larger countries or the population wise, when it's high population give?
I think it's by population area. I've forgotten now. One of those. Maybe we tried both, but I think it's population weighted. Yeah, but it may not. There are probably arguments to do either. Basically, the idea is that small countries can have a larger variance because they're small, and large countries, everything equals out a bit more and the variance is lower. So you give high, so then econometrically, statistically, it makes sense to, sort of heteroscedastic effect there is to weight the regression to take into account, which the result is you put more weight on larger countries, whether it's population or area that you use to weight them. Yeah. So yeah, so there is a greater weight on the larger countries. So in the cold spell, there is also, but only in the longer run is there a positive. That seems a bit odd, but so floods definitely seems to be the most important one where there's initial impact and as well as a longer run impact, positive impact.
Could I just ask, the long run, you said that's a couple of years?
Yeah, basically because the further lags were statistically insignificant.
Okay,
But yeah,
because I'm wondering if that like positive effect is still really only showing that, like if you think about those schematic graphs, only really showing the recovery, not where it actually equalizes out to in the long run. If you think, you know, you might be going 3 years, you could still very much be in a building back, not falling back down to an equilibrium.
yeah. But basically further lags were not statistically significant, so we dropped them.
Okay.
That is just a power issue, is that right? I'm just wondering, in the time series, so here you're exploiting time series variation in.
Yeah, it was a panel data, yeah.
Right. And this will be dominated by India and China?
There'll be more weight on them and the US and yeah.
Did you try anything to like only include, for example, some of the bigger ones? So for example, in MDAP, if you've got a bunch of events in there where you've got a bunch of events in MDAP that are, you know, 10 deaths or something, and so that country is then being declared as having an event in that year. Did you try and push up the threshold at all just to capture the larger events and see what's happening in those?
We did a lot of different iterations earlier on of things. We haven't here, but obviously it didn't really make much difference. Yeah. Okay, so we also looked at the impact on different categories of expenditure in the GDP. What we see is in the initial year, this is just floods. In the initial year, there's a positive effect on government expenditure. And then in the long run, all the components of GDP are increased. So it looks like sort of starts at government expenditure and spreads to the rest across the rest of the economy and all the other sectors in the longer run. So that kind of makes some sort of sense.
Can I just ask, I imagine developing countries would be more likely to receive aid in the event that they have a disaster. You're not likely to send money to the United States.
Yeah.
It might be different, but mostly you're not going to do that. Which would mean that there's actually an exogenous factor going into the GDP for those developing countries. They're actually getting an infusion. Where would that play out in this?
We did regressions of effect on foreign aid received, and there wasn't a significant effect, strangely. Yeah, so that's in the appendix at the moment of the paper. And we also looked at trying to distinguish between the effects of precipitation. The one thing with a flood is, right, it rains, the rain is good, right? Maybe good for agriculture, but the flood is bad. So we looked at controlling for rain and didn't change the results either. So yeah, so those are in the appendix of the paper we have at the moment. Yeah.
I'm wondering whether you were able to look at relationships between disasters, so that and their impact on society. So, for example, cascading and compounding disasters within one country, and effect on GDP, or concurrent disasters in different regions effect on GDP.
Yeah, I think we already had a question about the sort of number. So we didn't have a number of disasters as so it just looks at, is there a disaster this type in this year, but there's one regression, so it will include either disasters of a different type simultaneously in the same year. They'll be both have a one value for the dummy variable for that sort of disaster in that year in that country. That's the extent it will do it. Okay. This one's pretty puzzling though. So it looks at which sectors of the economy are affected in certain broad categories of production side of the economy: agriculture, forestry, fishery, manufacturing, non-manufacturing services. You'd expect the non-manufacturing to include this industry, not include manufacturing, includes construction to be positive, but it's not. Well, it's positive, but not statistically significant. So that is a bit, those results are a bit of a puzzle. They don't get a bigger number on here, which includes construction, but also mining, right? And some other, and power generation. So those are all in the industries which are not manufacturing. Yeah. Bundled together. We use a World Bank data, so we get finer grain, break out construction, but then that will limit your data more. Okay. So that is sort of that paper. I just want to show you the results of that, and there's a lot of good questions already on that. So climate change. This is really preliminary compared to that. I thought ski slope where there's no snow really is a good. Maybe it's not really climate change, but a way to represent climate change. So this is quite a. I always tell students to have a clear research question, and I don't really. I just want to improve the existing thing. It's pretty vague research question. And to illustrate that, I'll show you what has been going on in this literature on the effects of climate change on GDP using historical data, which people are then using to stick in integrated assessment models and so forth. The sort of term people use is damage functions. Like in the Nordhaus's DICE model, which is a very, very simple integrated assessment model. So the earliest work on this, and some of these papers are quite recent, and this includes papers by Nordhaus, who won the Nobel Prize in economics for his work on climate change, and Mendelssohn, one of his associates and other people. So he looked at a cross-section of countries. So at one point in time, or states, or counties even in the US, and the level of temperature and the level of GDP per capita. And say, well, if it's hotter, maybe GDP is lower. And we're going to use that to sort of calibrate our damage function. But of course, this might not have anything really to do with climate change, let's say. It's just, well, we know that developing countries tend to be near the tropics, and developed ones tend to be, apart from Singapore, maybe one or two others, towards the poles. So what is it really picking up? So maybe it's not really the effect of climate change, and a lot of other emitted variables which may be important, which so it's hard to know what this really means, though like Nordhaus work. So Richard Toll published a meta-analysis beginning of this year of all this literature, and he found that that set of literature, it shows a 3 degrees Celsius warming lowers GDP by about 2%, which is not very much compared to what typical climate change science people might think. So effects here extrapolated from this literature are quite relatively small. So because of this problem, does it really capture climate change? And the problem of emitted variables, the sort of next sort of wave in this literature, which includes papers by people like Melissa Dell et al. They look at the economic growth rate on this side. They use panel data, so observations in countries or states in years, and the level of temperature on the other side. Because there is a constant for each country, this mostly represents, therefore, the change in temperature, but the level of the temperature within each country. With the assumption here, because this is the level of temperature, is it warms up, it stays warm, then the growth rate is economy is permanently depressed. Okay, so even though the temperature is no longer increasing, but that warmer world has lower economic growth is the a priori assumption of this regression. It's changed a small thing, but it has profound effects. Okay, so it's a permanent effect. The meta-analysis results from Richard Toll shows that 3 degrees Celsius of warming lowers the economic growth rate by 1 percentage point. Now, that doesn't sound like a lot. It's 1 percentage point of economic growth less every year, forever. Well, until the temperature eventually goes back down. Right, so it results in it has large effects, in this literature, by this tweak in the parameterization or the estimator that's being used. Yeah.
How uncertain is that? So I mean, within the analysis, what's the sort of range that you get? And I'm not.
Oh, he is quite a wide range across the different studies in that meta-analysis all over the place. Yeah. That's sort of the average. Average effects here are much larger than in that first literature here.
but I get the point is it's there's a hit to GDP, which is relatively small, and then there's a bigger hit to growth.
In this literature, it's assuming that it's a permanent effect on the growth rate unless temperature eventually comes down again. So as long as it remains elevated, that the economy is not growing by 1% a year, not 1% lower. It's the growth of it is 1% lower, which cumulatively adds up to much, much bigger number. So this little tweak results in quite different results. So because of this assumption, some people didn't like that. So then they did this and they looked at the change in the temperature on the right-hand side, but otherwise kept everything the same as before. And so this says when delta T is 0, so when climate change ends, but the temperature is still elevated, then the growth rate bounces back to where it was before climate change ever started again. So that little tweak makes that assumption. So reverts back to normal once climate change ends, but it's warm, it's hot, but it's not changing anymore. Okay, so in this,
The change, what's the change from when?
well, these are annual changes in this literature. So it's annual panel data. And so they're measuring based on, which I'm about to critique, they're measuring annual changes. But yeah, it's if those are 0, then growth bounces back to what it was before we ever had it.
So if it was 3 degrees higher than.
Only 3 degrees higher, but we
then the next year it's 3 degrees higher still. That doesn't matter.
well, yeah, there'll be a big hit in growth in those particular years when the temperature is rising. Right. So again, the overall effects from this literature are smaller again. So yeah, okay. So problem with this latter one is it's looking at annual changes in temperatures and what's the effect on annual growth in GDP. So if you have a heat wave in 1 year, you're not going to adapt very much to that because you're expecting it to be different again the next year, and it probably doesn't capture some of the longer run effects of climate change very much either. Things like species extinction, 1 year might not hurt them too much if it bounces back again the next year. So I think there's a couple of the problems with this. So my thinking was, rather than looking at annual changes, tweak this model to have changes over decades. Okay, so we look at the GDP change over like 30, 40, 50, 60, 70 years, and the temperature change over that period. Problem with this is we end up with far fewer observations, and so not very so high levels of statistical significance, if you like, high levels of statistical significance. So this is the change over a long period in the country of temperature and change in the GDP, and that focuses on the long run changes. What's going on, there's another thing not really discussed in the literature is that we're interested in the effect of temperature on GDP, okay? But we already mentioned the warmer it is, typically the lower the level of GDP is. The lower the level of GDP is, typically high levels at least of GDP tend to be associated with low rates of economic growth and high temperature and expectations with that climate change will be greater as we go towards the poles away from the equator as well. So if you don't control for any of that, you could end up also with a spurious relationship between these two variables. So you definitely want to control for the initial level of a GDP and maybe their direct effects from temperature. You want to control for that. So actually control for both those initial levels as well. Okay. I just used the data Tim sent me. He instructed from, I hope it's good, and some other data. So these are the kind of results, different length panels. So I'm measuring change over 70 years, right? Or change over 30 years. The smaller that period, the more countries I can work with as well. So up here, I got minus 0.58. What does that mean? 1 degree of warming reduced GDP by 0.58 log points, which is huge. As the effect of historical warming, I think it's pretty implausible, but that's the result I got by using long differences rather than annual differences. as we shorten the period, but also increased the number of countries, this effect got smaller. And it's the length of period. This used the same 55 countries, and the effect also gets smaller. So it's something to do with the length of period. Okay. This is the very big effects of the longest periods there. Very, very big hits the GDP. To me, implausibly large. 1 degree of warming reduced GDP by 0.5 log point. That's like 50%. Something. Yeah. So this is the traditional fixed effect results, which these guys were doing. Okay, so I'd estimate that on the data. Use annual changes. So this is no control variables. This includes the initial control variables. This is 100 times smaller using annual data. Okay, so something very strange is going on. So I told you it's very preliminary. But so, for example, Tim added globally trade-weighted temperature changes in other countries, and also got a very different result. So here I use long differences and got a very different result. Yeah.
So a couple of quick thoughts.
Yeah.
One is year-to-year temperature changes have got a really quite weak climate change signal in it. Because
Yes, that's what I think.
year-to-year variability is dominated by natural processes. Climate change doesn't, so post-Second World War, so 1950 to say mid-70s-ish, waving my hands quite a lot on the definition of mid, climate's broadly constant, and then we get kind of broadly rapid warming at 0.2 degrees per decade from then on, with kind of decadal variability around that's quite small. So I mean, to me, it would seem that you could do something quite useful by thinking about, say, 1950 to 1980, where we have no climate change really, and 1980 to 2020 is different. But I guess the problem we've also got is the economies of the world feel very different. But maybe that's just my looking back and mythologizing.
Yeah, so splitting that sample. So you see here the first row here with using this fixed effects. It's got positive effects when we only use the 55 countries over a long period, because, well, those are mostly developed countries.
Yeah.
We're going to be benefiting from climate change.
70 to 2017. Yeah, I mean, those are weak, aren't they? They're not significant.
But the one with the very small effect is controlling for the initial levels of the variables. Yeah.
But if you look at, say, 1970 to 2017, that's when I think you begin to have a climate change signal in the record. Well, there is a climate change record from 1950 to 2017, but
you're suggesting drop the longer ones.
actually you get more data as you go later, and
More countries, yeah.
the warming only really kicks in from the mid-70s.
Here, from 1960 on, these are quite similar results. For this, well, yeah, all these numbers are smaller. And these ones are strangely large for these longer. I
mean, the issues, of course, with you've got.
You said that even though there isn't much climate change in the first 20 years. The effect is anyway. So strange, something odd.
Can I raise a point? So back to the previous slides. If we look at the p-value for the short-term predictions, the p-values are really high, which means those are not really statistically.
Oh yeah.
So do we have less confidence in terms of the short-term projection?
Yeah, these numbers are smaller and not significant. The reason why this isn't significant and this is sample size. So because we've averaged over many years, we've got far fewer, use up a huge amount of degrees of freedom in doing that. Yeah, we're doing anything like these sort of long differences between estimators and these things. They gobble up all the degrees of freedom to try to remove some of the shorter term noise and focus on the long run. Yeah. Yeah, so none of those is significant. Yeah. Another issue that hasn't been mentioned in the so maybe the last sort of point I'll make is that one thing that's not been raised in the literature is that the usual assumption here is these regressions are legitimate because to regress GDP on temperature, because your own emissions of carbon dioxide, methane, and so forth don't have much effect on your own local climate because it's globally mixing gases, right? And maybe you're China,
Sorry.
or China's the beers, yeah, but or you maybe it does, but I haven't actually seen that expressed clearly, but I think I maybe haven't read closely enough. But that seems to be the assumption that every country is affected by emissions of all countries and not just by its own. So it's legitimate regression. But something that definitely affects your climate, which is driven by your economic growth, is that local air pollutants, like sulfur dioxide and the black carbon, organic carbon, all these other things, they're affected by your local economic activity and likely to affect your local temperatures. Nobody's control for that in this literature. So I tried to, so you have this other sort of feedback loop here to temperature. So I tried to control for those air pollutants. I got more similar numbers across all the different panels, but still not perfectly similar. When I controlled for that local air pollution, which represents the feedback, it's not really statistically legitimate to do that. Because that local air pollution is an endogenous variable, so we can't include it as a control variable. So really you need to find some what's called an instrumental variable for temperature, something that drives temperature but is not driven, but is clearly exogenous to economic growth and doesn't affect economic growth except for only via change in temperature. So that was pretty. That is pretty tough. And I tried a couple of ideas so far, and with crazy results. So I think they probably affect the GDP via other channels. So that is definitely all this. None of this literature considers the effects of growth on local air pollution and reverse causality that might be affecting these results. Okay, so conclusion. Results are very sensitive to specification, estimators and control variables used across all this literature and also the experiments I've done and that Tim did. My initial results of his long difference estimators seem, for the longer panels, implausibly large. For shorter periods of time, they're not statistically significant. Maybe that, I don't know. So needs more work to try to understand. And that's why we need a grant. one of the many reasons to do more research on this topic. So that's really just an exploratory part research on climate change aspect. Okay. So yeah, take other more general questions. Go back to things that I maybe rushed.
One question about the first few plots. You showed the number of severe kind of disasters, number of disasters in each country. Is there any correlation between the severity of the disasters and the numbers? And if so, have you controlled the severity in your models?
I don't think this database includes well, sure it does include the severity or it's comparable, because different ones it may be included because they declared a disaster. I'm not sure if it includes or data which yeah. So what is the best what is the best way of measuring that severity of a disaster? So we gave up on measuring. There is some data on death tolls, I think, but we gave up on using that because that's maybe not comparable across the different. So what we're measuring is the average effect of a declared disaster of some sort, which is in this database. And is it positive? Is it negative? Is it a permanent effect? And no, with all the caveats that to that.
So one of the things that I've never understood about economic modeling, well, one of the very many things, you use global temperature. And I don't quite understand why you use global temperature per se, because I don't feel that global temperature is where the rubber hits the road in terms of economic risk. So my question is,
I'm not using global temperature.
you're using
Temperature in countries.
yeah, but still,
Yes, still. yeah.
what happens if you delete any notion of temperature and replace it by rainfall?
Very noisy.
Yeah, we've got rainfall in the database. Some of us, I haven't used rainfall. I haven't done that myself. The reason I haven't done it is it's that, well, it may increase in some countries due to climate change, may decrease in others due to climate change. So if I want to look at the effects of climate change, so that, yeah, so you definitely can look at the effects of precipitation, yeah, changes.
But in climate, at least my view is in climate science, change in temperature is used as an indicator.
Yeah.
I don't think it's the change in temperature, it's the consequences of the change in temperature on many, many other things that leads to the impact.
Yeah.
Now, that's not true of extreme heat waves, of course, but it is true of many things. So if you take agriculture, for instance, agriculture benefits on average from warmer temperatures. Sure as hell doesn't benefit from an absence of rainfall.
Yeah.
I just wonder to what degree the economic modeling has a fundamental flaw at the base of the philosophy.
So if we regress the economic variable on change in temperature, right, and we don't control for any of those other things like rainfall and so forth, then all those mediating variables from this indicator variable of the temperature increased, it affects then the other things you're mentioning, which then affect the GDP. If you don't control for any of those things, you're including them in your estimate of the effect of temperature, if they're correlated with temperature, because you haven't controlled for them. So they're changing in line with, you're measuring with temperature change. That includes everything that's correlated. If you don't control for a variable, then all the other things which are changing in alongside the temperature, in, well, proportionally to it, let's say, that's a critical assumption, linearly proportionally are then included in your measure of your estimate of the effect of that temperature change, that climate change on GDP.
Okay.
Because you didn't control for them, so they're changing. So often it's a problem that we don't control for things because we want to isolate just purely the effect of temperature. If you just purely want to isolate the effect of temperature, you need to control for all those other things. So in the US, temperature is a proxy for climate change. You don't control for anything of that sort, and then you get an average effect of anything that's moving in each individual country level. Where if you broke it down further, you could go further. You had the data at state levels or grid levels or whatever. Tim was interested in breaking it down to the sort of grid levels. So this is very preliminary sort of research. Yeah, I'm not sure I lost my train of thought there.
If you take China as a good example, if Western China rainfall increased by 30%, but in Eastern China it reduced by 30%, you wouldn't pick that up, would you?
Not if you have China as a unit of analysis. Yeah, you've got the average of both. Yes, well, that's the problem. The problem with the countries are different sizes. Yeah. So one way people are trying to get around this is, I said, there are some countries do have economic activity data at the provincial or state level, or there's this night lights data. I'm always skeptical about it, but it seems to work. So we can get down to like a grid square level degrees, or even down to the, I don't know what the smallest level units of analysis that makes sense. So yeah, Tim wanted to. That was also included in our expression of interest. Hasn't got up. Yeah.
I have a question. Yeah, thanks. As a follow-up, another problem might be that effects are non-local. So if you take the local temperature, that doesn't mean that's a climate change effect in that same region.
Yes.
On all the other variables you're not controlling for. So even if you include the effect on the other variables of temperature changes, it's going to be non-local. For instance, if you get more rain in one place, it's probably going to be cooler because you've got more rain, but it might still be driven from a warming somewhere else.
Yeah, so Tim included in his paper the trade weighted, I think, average of changes in all countries in the world for each country. I agree with you, it might be a biophysical process rather than an economic process, but he weighted them using size of trade flows between countries, but you could just have a spatially weighted or so that is a possibility to include those non-local effects as well. I was here more looking at the stage of like, well, try to focus on the longer run and some of these other biases, what happens to the results that we haven't been addressed, what happens to the results we get. But yeah, that's an obvious extension. Yeah.
I might have a couple of questions. So maybe the simplest analogy that my dad told me about economies is like, if you want to boost the GDP, you hire some people to dig a hole in the ground and then hire another bunch of people to cover the ground. Like that will naturally boost their GDP. So overall in this analysis, are we referring to the nominal GDP or real GDP? And is there a way of capturing the real productivity associated with climate change?
Digging holes and filling them in again only makes any sense if those people are otherwise unemployed, right? So if you're taking them away from more productive activities, your GDP will fall. So if you've got mass unemployment like in the Great Depression, yeah, it made sense temporarily to find, not as useless as that, but things that produced longer term investments which maybe wouldn't make sense to do usually when people were otherwise gainfully employed. So it's not quite as silly as that, but there are plenty of good critiques of. Okay, and what was your second point?
So are we using the nominal GDP or real GDP?
Well, nominal GDP doesn't adjust for inflation, and real GDP adjusts for inflation. So everything's adjusted for inflation. Yeah.
Yeah. So which one?
Yeah, real. It doesn't take. So real just divides the GDP by price index.
Okay. Yeah. And I do have another question. So I've noticed the analysis was based on 1960s to 2019, which is before COVID.
That was on
But if we consider the situation like with COVID, US has boosted so much US dollars into the economy, which will naturally raise in inflation. And then there's like possible like changes in the global trade based on the geopolitical situations and then evolvement of technology. So do we think this analysis will be applicable to the future scenarios?
Well, it's always, it's a bit like they say about investment performance, that it doesn't necessarily predict the future. One hopes that there's some sort of stability in results you get to predict the future. But I think we're seeing in this literature that results have changed over time as newer data has come in, so that probably governments maybe are doing more to reboost up their economies after disasters than in the earlier periods. One thing we probably should do is break this data down into sub periods, which we haven't done, because that reduces your degrees of freedom again. It's always a problem. But yeah, so we updated by a few years. Would it change things a lot? I'm skeptical. Yeah, we put that cutoff there at that time. Yeah.
This is a really naive question, but if you're using annual observations and you've got, like, as we saw with the floods, 200 observations in India, is India ever not in a position of crisis? And does that actually mean that some of these countries actually are you only ever have them almost in crisis? I mean, even in this one, a number of countries are approximately a third of the years.
That's actually a pretty good question. Yeah, should have a look at that.
Because you could possibly take those countries out Because they may be really making a mess of things.
That sounds like a good idea to investigate. Are there years when India is not having a flood?
Or a cold spell or a warm spell or something.
The other things I think definitely there are the floods though is a very good question. Yeah. Something we should investigate in our before we resubmit the paper.
Any other questions? I guess I had a very general one just about, that I think came up earlier, the focus on GDP as the thing that is. Is that because it's the most convenient measure that we have? Are there any other attempts to do this using different indicators?
Yeah, it's the most convenient thing to do, which we got over a long period. Data being reconstructed at least over a long period of time. Well, there's some other sort of development indicators, adjusted GDPs, kind of things. Those are pretty arbitrary how they're adjusted. Economists tend to think so. But yeah, you could look at other development. But I would favour more using other indicators of development. You want something though that does change, that is likely to be impacted relatively quickly to measure effect in the short term. But like literacy, for example, how's it going to impact that? You'd have to look. There, if your results going to have any effect, it's going to be quite long term till you can measure that effect. It might be quite a small signal, lots of noise. So I don't know. We haven't done that. In theory, you could try it. Yeah.
Okay. All right. Well, with that, please join me in thanking David for a very stimulating. Thanks everyone for coming along to the seminar. We've got a bit of food outside, so do stick around for refreshments and for a bit of chat. And do keep your eye on the ICRR website. If you're not already a member, please sign up and get information about upcoming seminars. I think the next one next month is by Samantha Stanley, who's a DECRA fellow in that institute.